Welcome everybody. Today we are going to look at 6.4 applications. So applications have a lot to do with projectile motion, so objects being kicked or thrown or shot out of a cannon. So looking at the first one, let's first look at the graph. So this graph kind of shows you different parts of projectile motion. So when something is like thrown, it creates this parabola. So it starts off here, maybe something's like on a building, and then it gets thrown off. And as it goes up and up, it reaches a vertex. So the vertex is the top of the motion. So it's the highest it's ever going to get. So the vertex is like your maximum. So the x value of that is your max height. Usually the x value we talk about as the time. So your x-axis is going to be time a lot of times on these. And then your y value is how high the object gets. So the height of the object is the h. So the y-axis is going to be the height. So as we look at these different scenarios, a lot of times we'll be finding like the maximum height. So we'll be finding the time and the height of that maximum value, which is called the vertex. And then we're going to look at when it hits the ground. So here it hits the ground. So when things hit the ground, their height is 0. So we'll look at what happens when we set the height to 0 and how to find the time. So you can kind of look at that picture, but those are some basic things we're going to do with it. So the first question says, a soccer ball is kicked from the ground with an initial upward velocity of 90 feet per second. The equation is height equals negative 16t squared plus 90t, gives the height h after the ball after t seconds. So notice that 90 fits into the equation. So quick sketch of this scenario. So we've got a little person, and they're kicking a soccer ball. So they kick the soccer ball, and on this graph, their height of the ball is the y-axis, and how long the ball's been in the air is the x-axis, so that's our time. The first question says, how many seconds will it take for the ball to reach the maximum height? So the maximum height, remember, is at the vertex. So the vertex formula is x equals, or in this case, time equals negative b over 2a. So I think we saw this briefly in our quadratics unit. So in this scenario, the a is with the t squared, the b is the t, and there's no c for this one, so c is 0. So if I wanted to find the time, we would do negative b, so negative 90, over 2 times a, so negative 16. So if I type it into a calculator, I get 2.8125, and that's our time, so it is the seconds. So that's how long it takes for the ball to reach this maximum height. So that value is right there. So that's the 2.8125. So if we wanted to find the maximum height of the ball, the height then would be the y value there. So we would plug in the seconds to find the time. So plug in t from the vertex to find that maximum height. So we're plugging it into this equation. So we're going to do h of t. So t now is 2.8125. So it's replaced our time. And then every place we see a t, we're going to replace it with the 2.8125. I know normally I round this number. I want to get as accurate as possible of a height. So that's why I'm just keeping it as it was, because it didn't go on forever. So then I would type this whole thing into a calculator, and it tells me 126.5625, and that's the maximum height, so height is the feet. So we just found how long it takes to get to the maximum height, and we found this maximum height is that 126 point stuff. So looking at another example, it says an apple is launched directly upward at 64 feet per second from a platform 80 feet height. The equation for the apple's height, h at time t, seconds after launch, is this equation. What is the height of the apple after 3 seconds? Okay, so the question is, what is the height? So the height is what we're searching for after 3 seconds. So that means our time is 3. So good news, we know the time. So to find the height, we can plug in the time. So it would be height of 3, so h of t equals negative 16, 3 squared, plus 64 times 3, plus 80. And we type that into a calculator and we get 128. So after 3 seconds, we are 128 feet in the air, or the apple is. Those ones are my favorite because all I have to do is plug in the T. Easy peasy. All right, we've got a toy rocket. It's launched vertically upward from a 12-foot platform with an initial velocity of 128 feet per second. Its height h at time t seconds after launch is given by this equation. How long will it take the rocket to reach the ground? Okay, so the question is how long? So that means our time is what we're searching for. To reach the ground. Okay, so if you think about it, if this rocket's being launched, when it hits the ground, the height is 0. So if we know the height is 0, I can replace the height with 0. So it would look like 0 equals negative 16t squared plus 128t plus 12. Ooh, I know those are t's and not x's, but in the past, when we've had an x squared, an x, and a number, we could try factoring, we could try graphing, we could try quadratic formula. So that is how I would personally approach this one, is the quadratic formula. So this is my A, my B, and my C. So we've got x equals negative b, so negative 128, plus or minus the square root of b squared minus 4ac all over 2a. So, I know I wrote x equals, but really, instead of this x equals, it's like time equals, because t is our x in this scenario. So our time equals, if I simplify that, negative 128 plus or minus the square root. Remember, we always simplify the inside of the square root first, just in case we get imaginary numbers, all over negative 32. So when I take the square root of that, it ended up being like close to 131. So I rounded this number. I just wanted to get a nicer answer. If you didn't round it, that also is fine. So remember, when we have the plus and the minus, we've got to split it up. So I'm going to do negative 128 plus 131 over negative 32, and negative 128 minus 131 all over negative 32. So for the first one, when I typed that in, I got around negative 0.09, and the second one, I got 8.09. So this was our time. So does it make sense to have negative 0.09 seconds? It really doesn't. So because that is negative, we ignore it. So you can't have a negative time. But the 8.09, that is a time that works. So that is going to be how long it takes to reach the ground. The reason we get that negative time is if you look back at our original picture, this parabola extends over here. So that point would be the negative 0.09. And this point is going to be the 8.09. So it's kind of like if we'd gone backwards before we threw the rocket. So it doesn't really make sense in the story problem, but that's how it would complete the parabola. All right, let's look at a penny. So a penny is dropped off the Empire State Building, which is 1,250 feet tall. If the penny's pathway can be modeled by that equation, how long would it take for the penny to strike a 6-foot person? Ooh, kind of morbid. So how long, that means time is what we're searching for. A 6-foot high person, that's a height, so our height is 6. So what we're going to do is we're going to replace the height with 6 and solve for the time. So it looks like 6 equals negative 16t squared plus 1250. Ooh, this one just has a t squared and no other t, so we can use my favorite method, which is square roots. So we can subtract, if only I could write. So we get negative 1244. Then we divide. Negative divided by negative gives us a positive, which is good. And finally, we want to get rid of the squared, so we got to square root it. So our time is 8.82 seconds. But wait, you might say, Miss Pinkston, you need a plus or minus. However, it's not going to be plus or minus because, can we have a negative time? No. So it's because you can't have a negative time, so we only want to have the positive answer, not the negative answer. So in a non-story problem, yes, we need the plus or minus, but in this scenario, only the positive answer makes sense. All right, let's look at some fireworks. So some fireworks were fired vertically into the air from the ground at the initial speed of 80 feet per second. The equation for this object's height, h, at time t, seconds after launch, is that equation. What is the maximum height the fireworks reached? Ooh, we've done this. Maximum height. So we're trying to find the vertex. So in this scenario, we first have to find the time that it hits the vertex, and then we're going to plug that in. So a reminder, the vertex is at negative b over 2a. So this is our a, our b. So the time would equal negative 80 over 2 times negative 16. When I type it into my calculator, I got 2.5 seconds. So that is how long it takes to reach the maximum height. Now we're going to plug that in to find the maximum height. So we're going to do h of 2.5 equals negative 16, 2.5 squared plus 80 times 2.5. I typed it into my calculator, and it turned out really nicely. It was 100. So 100 feet is going to be the maximum height. So when it asks for maximum height, it's kind of two steps. You first have to find the time, then you have to use that to find the height. So this vertex formula is an important one to know. All right, our last problem. Ava is jumping on a trampoline. Her height h at time t can be modeled by that equation. Would Ava reach a height of 14 feet? Ooh, okay. So this one's interesting because we're wondering, could we ever get to 14 feet? So when I think about this, the highest that we could possibly get is the vertex. So we're going to find the vertex and then compare it to the 14 feet. Sorry. So we're going to do t equals, this is our a, b, and c. So negative b over 2a. So I type it into my calculator and I get 0.625 seconds. So that's how long it takes Ava to reach the highest point. So then we're going to plug that in to find the highest point. So height of 0.625, so negative 16, 0.625 squared plus 20 times 0.625 plus 6. So I typed that into my calculator and I got 12.25 feet as the maximum height. So the question is, would Ava reach a height of 14 feet? Well, if 12.25 is the maximum, no, she wouldn't, because she never would reach 14, because the highest she's reaching is 12.25. So the max is lower than 14 feet. So she never reaches 14 feet. Probably for the best. Trampolines are kind of scary sometimes. Like, they're really fun, but I don't know, when you get bouncing so high, I feel like I had a friend that broke his elbow when I was a kid. That always freaked me out. Okay, so the max is lower than 14 feet, so she never reaches 14 feet. So the answer is no. All right, hopefully this is helpful. Definitely use that vertex formula to help you find the maximum, and use your quadratic skills to do some solving. Good luck, and I hope it goes well.